Starting to taper off a bit on the signing ons coming in. I see the numbers are still rising a little bit, but I think it's 2 minutes past 4. Let's get going with this webinar, Power Hour. So thanks for joining. We really appreciate you standing off the time to join us live for this, and everybody that's going to watch this recording, thank you as well for that. Thanks for joining us for this TBC Power Hour, working with surfaces and contours. My name is Albert Willefeer. I'm the Technical Product Manager, and we'll take you through this Power Hour. With me is VM. He's our Server Office Software Product Marketing Intern. He'll monitor the Q&A section. So guys, any questions, please add it into the Q&A section. VM will answer as he can along the way. At the end of the session, we'll also have a brief look at the Q&A if there's time, and I'll answer some questions on live if possible. Otherwise, we do have a printout of these questions that you guys ask, and we'll reach out to you in due time if we don't get around to answering all your questions that you have. I will be launching a poll now as well. So guys, if you don't mind, it's 3 quick questions and not a lot of info you need to put in there. If you don't mind, please completing it. It really helps us just gauging a little bit where we are in terms of TBC and what you guys would like to see happening in future as well. So that poll is now live. If you guys don't mind, please complete it as we go along. I will leave it open until the end of this webinar, so you don't have to worry if you don't want to do it immediately. But if you don't mind, as we go along, please complete that for us. We appreciate it. Good. There's our beautiful faces, just for you guys that haven't seen us before. Myself, Albert, and VM on the right. For today, what I'll do is I'll just do a few quick slides. We'll just look at surfaces from survey data, as well as surfaces from point clouds. We'll look at surfaces plus volumes, some additional surface tools, and then contours as well. So we'll just have a brief overview of everything. Just explain to you guys exactly where TBC is at the moment regarding all these functionalities, and then I'll do a bit of a live demo with a few data sets, showing some hopefully tips and tricks for everyone and some interesting things you can do in TBC, and hopefully you will learn some nice workflows for the future. First up, surfaces from survey data. So taking in your raw data, feature code library, if they have that, process your feature codes to help out with the line work and the CAD work. Once that's done, you can create your surface. And once the surface has been created, you then have obviously a few options to clean up the surface using various tools. So including the line work and points and other CAD elements to define your surface can be done. When you create your surface and the cleanup is needed, you have certain settings for the rendering, triangulation settings. There's also there's also an option to flatten surface to remove some outliers, which I will also show a little bit later in the live demonstration. Use case and deliverables, obviously export as a TTM file for machine control, LandM XML for third party. TTM file can also be used for checking of your earthworks. So if you want to compare the surface to what's actually in the field, you can stake out using that TTM file to see the cut and fill values as you go along. Using it as a field data QAQC, that's just what I mentioned. When you use that surface to go check it against what's happening in the actual field, obviously you can use it to include in your plan sets, and then surfaces is used for volumetric calculations. If we move on to surface creation from point clouds, a little bit different when using point clouds compared to your conventional survey data. Classifying your region commands to extract ground. So that is quite handy when you just want to extract the ground. As you can see on this top right picture, the brown is actually just the ground that's been extracted, and the rest of your point cloud is classified into different regions to make it easier to do a ground surface using point cloud data. And you can run it a few times if you want to enhance the quality of that point cloud. check options to set desired number of points to include in a surface. As you can see on the top left here, you can actually tell TBC the maximum number of points to be used in a surface, as well as the maximum number of points in volume measurements. So that obviously just makes it a bit easier for TBC on the resources if you have a large point cloud, to actually use that to make sure you have a little bit less resources utilized when using these kind of point clouds. So it serves as a sampling function when using point clouds. Create surface cleanups as needed. So your properties to set rendering and triangulation again. Again, the flattened surface to remove outliers is there, as well as an ortho image as surface member to render. So you can actually drape your ortho image on top of your surface as well. Moving along to surfaces and volumes. So create volume commands for quick quantities, that is with lower accuracy. And then you have your earthworks report for the complete computation of the volume. So it gives you an HTML-based report, or Word customizable reports are available as well. And you have 3 different options in calculating your volumes. There's the stockpile depression option, surface to surface, where you compare 2 surfaces to each other, or then a surface to a specific elevation that you would like to calculate. At the bottom left, you can see the earthworks report that you will get out when using that in TBC. Additional surface tools. I'll just quickly run through this. I won't touch on this today in the demonstration, but just for you to take note of, there's obviously 2 3D cross sections, surface slicer views that you can get to interact with your surface and extract the needed info. Cut full maps, that's obviously utilized for reporting and inspecting on earthwork operations. For your surface intersection, we have surface to object options, and you create stakeout points and lines as well with your surface. Projected surfaces, that's where you have a vertical surface, as you can see this dam wall at the bottom left here. So there you can actually define a custom plane to project a surface to support vertical surfaces. So obviously when you have this kind of example, or high walls in mining in pit, or when you mine in a pit and stuff, that's the way that you can actually utilize the projected surfaces to get a vertical surface into TBC as well, if that's needed. Lastly, contours. If you look at the contours, it's all dynamically linked to your surface. So it automatically updates when your surface member changes, or if you change anything on your surface itself. Preview of contour settings before created. So you'll see, as an example, down at the bottom right here, you'll see you have your surface information, and it will tell you the number of contours that it estimates it will be generated. So obviously it gives you a good indication what your interval level is, and if it's going to be good enough for you to visualize, or if it's going to be way too many contours and you need to change the interval a bit better to get a better contour interval for your surface that you have. And then contours can also be stylized like any other text in TBC. As you can see, 2/3 down here, the text style standard, the distance between the labels, and you can then change that text style to suit your needs for what you want going into this. Good. That's a quick rundown of where we are with surfaces in TBC, what can be done with surfaces in TBC. So let's have a look if we go into an actual demo of a few of these examples that we just explained. So up and running with TBC. Hope everyone can see that. Looks like it's there. Great. So first of all, first one I'll do is I'll just waiting there for TBC to open up. 1 second. Sorry about that. I think my headset just turned off. I hope everybody can still hear me fine. Good. We have TBC open up. As you can see, this is a conventional survey, that TACI survey that was done with GNSS and total station information. The blue lines obviously indicating the GNSS data, and the green lines the total station data that was done. There was a feature code library that was used. As you can see, if I click on the drop down, you will see there is the feature code library that was used for this, with all the different entities. I've already done the processing of this. So if I switch off the raw data for the RTK vectors and the total station, you will see that we already have line work done. Some vegetation was as well done, some lampposts and so forth. Okay. So for this example, what I will do is I'll first of all just create a surface. So if you go to surface, create surface, I'll just use the points in this project. I won't be adding any line work for the time being. And I'll show you now why the reason is for that. So I'll go to create surface. I will give it a name. You can then classify if this is work in progress, as built, as you see fit. You can then choose what color the triangles would be or the surface would be. And then you have an option to do a survey date as well. This is beneficial if you're doing, if you are doing volume calculations on stockpiles, or you're measuring earthworks that is being completed or changed a lot. You can always add the date of that specific surface that you're going to create in there, so you can then keep track of the progress of that surface going forward. So that's a good option there, and the time can also be added there. Then the members to form surface with. So this is where you select what you would like to include in your surface. And as you can see, I've just selected points, 463 of them. You can either click apply or OK. I'll just do OK. And then we have our surface completed. So as you can see, there is different ways of visualizing a surface. So what I will do is just quickly minimize that. So as you can see there in your drop down for surfaces, you will see my surface. If I select it, I right click and go to properties. You will see all the properties for that specific surface. Anything that's in dark blue, you will be able to change. So the name can be changed here. You can change the classification, the color, the maximum edge length. That I'll get to in one of the following examples to show you how that can be utilized. Tolerance, the flags, auto. And then the next is if you have a plan view or 3D view, you can decide what you would like to see in that specific view of that. So what I will do is I'll just turn that off to no. If everything goes to plan, there we go. And then if I unselect it, I should just see my triangles. If I then go to 3D view, we will then be able to manipulate the surface to see what we would like to see it displayed for us using the properties. So as you can see, there we have our surface, and you can change the properties by simply selecting the options of what you would like to see in that. So at the moment, it's set to elevation. If I change that to biomaterial, it will update that. I'll just keep it like that for now. Okay. One thing I want to change there is I'll just take off the wireframe, and we can see this surface without any triangles. There we go. So now we have a clean surface with no wireframe in it. So there we have the different ways of viewing your surface in either 2D or plan view. If I go back to the 2D view, first of all, what we will notice is that we have a very high point here. That's obviously the height of the lamppost, and that is something I would not want to have in my surface. There's a few ways that you can manipulate this in changing that without having to redo the surface completely. So first thing I will do, I will just select that specific point. And in your point options, you'll see you have an include surface, yes or no. So it's as simple as just changing that to no. and you will see my triangles already being removed. It will not include that point in any future surface that I generate. So even if I now select it for the new surface, as you can see there, this point will always be excluded from a surface. So that's a quick and easy way to remove. Let's see, that one is the same. We'll go in there, and again, if we remove it, the surface will automatically update as well. So that's an easy way to quickly remove points that you don't want part of your surface, and in future it will also not be included in that specific surface. If it's just a once-off and you want to create a surface without it, just unselect it as part of the surface members that you want to generate your surface with. Next thing we can do when it comes to surfaces, as you can see, we have a lot of triangles crossing over our existing CAD that we don't want to see, because that's curbs. We don't want triangles to cross over these specific lines. There are break lines as well that we can utilize. So in TBC, you can add break lines by simply clicking there and creating a break line. Or the next option is you have surface members. So if I close there and I view surface members, what can be done is now we can actually select what surface members we want to add to the surface. That can be points, CAD lines, objects, as you see fit. So what I will do is, let's quickly just switch off everything except the line work. And just quickly the surface as well. So all I do now is I can now just drag across. I've got all these members now selected. I'll turn my surface back on, and just to show you what will happen. So if you notice the triangles crossing, if I add, the update will automatically happen. And now you can see I don't have any triangles crossing over any of these CAD lines that I've added into that. So that's a quick and easy way to sort out your surface, to ensure that break lines by generating them by yourself, or if you have existing CAD, adding that to your surface and then manipulate your triangles that way so that your surface model will look correctly and not be incorrect in the model itself. As you can see, now we have a much better feel for our surface over here, and you can see nothing has crossed over those break lines that we have generated. Okay. So that's the way in using conventional data and CAD that you can easily manipulate your triangles. Simpler tools to do, and we'll go into it a bit later. If you want to swap triangles, it is as simple as simply clicking on that and you can manipulate the triangles. So you can still manually go and move around if you feel like it, any of the triangles that you want to. That's in TBC around here. That one's obviously close to 2 there. So you still have the manual availability there as well. Trim surface edge. This example isn't going to be that great for this, but I'll just quickly go. We can do that. So it's simply by clicking on the outside and then onto a specific point, and it will remove the triangles from that section for you. So that's how you can quickly trim the outside edges if you want to get rid of a few triangles that are not included in your model that you want. That will cover it for that. To do contours, let's quickly run through that process. It's not a very big drawing, but we can quickly do that. And if we want to have a look at the creation there, so create contours, simply select the surface. So you can have multiple surfaces and select which one you would like to utilize for generating your contours. So you can have multiple surfaces and have any of them available for you to create contours from. The name can be in there, the interval. I'll just stick it in 1 for now. Frequency, you can stick your own layer in there. So let's quickly just create a new layer for the contours. Okay, now we have the layer there. You can then decide on the contour line weight, can be by layer. You can index contour colors as well as index line weight if you want to. We'll just color contours by elevation just to show that, and we can smooth the contours to fit nicely onto the surface and not have too many jagged edges. As I mentioned, if you want to change the text, you can always go in there, create your own text style, and then manipulate the text as you see fit for your surface. Over here, you can decide if you want to have a big drawing and you would like to place labels every 100 meters, every 200 meters, depending on the size of your job, so that there is a label every now and again on long contour lines. You can instruct it here to do every 50 meters or whatever you feel the need for your surface that you have or the contours that you're going to generate. You can tick on and off if you want to label the end of the contours as well. So as you can see, for this drawing, I'm already going to have 23 contours that's going to be generated. So I'll just run with that and see what that looks like. And there you can see, obviously, we have a point over there that was not needed. So as I mentioned, everything is linked to each other. So if we go to that specific point, let's just switch on the points again. There we go. And we select that point, go to its properties. I can then remove it again from the surface, and it will update my contours as well. Okay. And as soon as that refreshes, contours should refresh as well, which is just my live demo. Doesn't want to happen for me at this stage, as it should be in a live demo. Sorry about that. We'll have a look and see what that happened. So there you can see we now have our drawing sorted and our contours linked towards that, as well as in 3D view that can be viewed with your contours included there. One thing I did forget to mention, if you do have a feature code library and you did not add, remove, or did not include in Surface a specific feature, just want to quickly show you. If you have, let's say, the broadleaf trees in the properties, you can see that I did include it in the surface. If you're measuring the height of the trees and you want to remove them, you can update this in your feature code library. You then just have to reprocess it and it will exclude all those points from your surface if you have that in there. So feature code library can also be changed and manipulated to ensure that the right points are included in your surface or not. Just remember that you need to reprocess your feature code library once you made any changes to it for that change to take effect on any of the work you've done. Good. Up next, we'll go into a bit more of the point cloud stuff for surfaces. Just open up the next project. Okay, let's just wait for this to open up. There we go. As you can see, as I mentioned, I have done the classification already. So if you go to the point cloud regions, you will see there are the different options for what you would like to classify. If you want to know a little bit more about how that works, I'll just quickly take you through. So under point clouds, you have the option to extract classified point regions. I'll just show you what that looks like when you open up the command. If you don't want to classify everything, you have the option to untick these boxes. So if you're only interested in getting non-classified and ground, you can just select only the ground and everything else can be ticked off. You select your point cloud, you run it, and it will then extract only the ground classification and leave the rest as not classified. So that's an easy way to quickly do a ground classification without having to run through everything to be classified that's in your point cloud. As you can see, this example, just go to 3D view quickly. This is a bit of earthwork site. And the higher vegetation was taken out there. And you can see what that looks like. Just to show you in TBC how to manipulate the surface there. So what we can do is, first of all, just move into your point cloud regions. And then we can actually switch off what we don't want to utilize. There we just have our ground surface available. So let's quickly create a surface for this. If you want to use less points in creating the surface and you don't want to sample it down, as I mentioned in the slideshow, if you go to options and you go to your point clouds, you can see that you have the option here to say what is the maximum amount of points in a surface definition that you want to use. So you can manipulate how many points get utilized when generating a surface by simply changing these values as you see fit. As you can see at the moment, it's at 500,000. And the same for when you want to do a volume calculation. You can also tell TBC how many points you would like to utilize when doing these calculations. Do remember, the less points you have, the less accurate the surface is going to be, the more, but it's going to generate much quicker. Obviously, the more points you utilize, the longer it's going to take, but the more accurate the surface and the volume calc would be when utilizing the more points. Okay, let's quickly generate a surface for this. I'll just leave it as work in progress. Do magenta. Again, you have the survey date and time that you can add this. So obviously, if this is work in progress, I can have each week and I can give it a specific date and time for when the measurement and survey was done for that specific surface. Simply select the point cloud region you want to utilize, either by clicking on there, or you can select it in your Project Explorer, and then simply go, okay. The surface will get generated. And as soon as it's done, I'll run into some properties so you can see what you can do with the surface to manipulate it a little bit more. I'll just switch off the flags. If you do see these yellow flags, especially when it comes to scan data, it is because there are points that are very close or one above another. That's simply because of the amount of points you get when utilizing point clouds. Chances are that you might find 1 or 2 points that are very close to proximity or on top of each other that gets flagged using those yellow flags. I'll just quickly switch that off so you can see the surface. Let's just unselect. There we go. And if I switch off the ground, you can see what the surface looks like. Pretty decent and quickly done. Same in the plan view again. Can't see that much. And if that is the case, let's go to the properties and we can then manipulate how we view this surface. So I'll select it and then go to properties. First thing I would do when I see a surface like this was generated, you'll see these large triangles that are over here. And obviously the same happened over this section. You can go into your surfaces and say trim surface edge if you want to. Another way that's far quicker that you can do is if you go to the maximum edge length, you can actually update this to say what is the maximum length of triangle you want to utilize. Obviously being a scan data, there's not going to be that much. So I'll just dim it down to 100 feet for this example. And you will see TBC will automatically update the surface once you make a change to that length, and it will shorten the triangles as you can see it has done already. So that's a quick way to manipulate your surface that you've generated to ensure you take out unnecessary triangles in your surface instead of having to manually go and do that the whole time. Over here, we still see over here, you can see we still have too many contours. Sorry, guys, I just want to quickly check something on my headset. Everybody can still hear me, all good? Just a thumbs up quickly in the chat would be good, VM.
Yep, everything is good.
Okay, thanks so much. Sorry, guys, I'm just having some issues with the headset. It should be good now. So obviously we can manipulate these triangles manually just to sort them out. Another way of doing this is if you don't want to utilize these triangles as part of your surface, we can use the surface member option again here as well in point clouds. It just works a little bit different to what we have. So what you will see is, let's quickly switch off the surface. If we switch it off, and I should switch on the ground, that will help. Here we go. So as you can see, this long section, I do not actually want that to be part of my surface. It's not going to benefit me, and it's not going to do anything to what I would like to see in the future of my surface. So I can actually go manually remove this. The other option I do have is I can actually go and select this. Oops, let me just select that first of all. That will help. If I go to polygon select, I can now go and select these scan points individually. Let's just make sure I get all of them. There we go. As you can see, I've now selected those specific points in the point cloud. And what I can do is I can now tell it to remove it from the surface. So if I switch the surface on and I tell it to remove, it will remove those specific points from my surface that I generated and update the surface accordingly. And there we go. So as you can see, easily manipulated my surface to exclude unnecessary point cloud points that I don't want my surface to enclose or be part of when generating that. So same can be done if you have specific points that we'd like to add. You have the functionality of adding them again, and the surface will auto-generate and add those specific points that you've removed from your surface. Okay, go back to the properties. View we did sort out. I just want to quickly see. The last one was just the maximum angle, edge angle. So it's just the angle of what's the smallest angle of your triangle. So you can obviously manipulate the triangles also that way by changing that maximum angle to be a little bit bigger or smaller to ensure that you don't have too narrow a triangle when generating any of the surfaces. So obviously, if you can think of that angle over there on the inside of the triangle, that's another way that you can manipulate your surface to ensure that you don't get triangles that's unnecessary or unwanted in your surface. Just want to quickly see just the summary at the bottom. So always remember, you can always see your maximum elevation and minimum elevation down the bottom. You can view the number of triangles you have in your surface, as well as the number of vertices, if you would like to get an idea of how big the surface is. In that sense, there is the information at the bottom there of what your surface entails. Just want to quickly see, there was one other thing. No, I'll do it in the next one rather. Yeah, that's good. So that's just a quick look at point clouds and how to generate a surface of it. So remember to classify it if you just want the ground. Another thing, that if you have too big a point cloud, you can always use the sample region option. There you can actually tell it, I just want to point every 1 centimeter or every 5 centimeters or 5 millimeters, whatever the case may be. And you can sample your point cloud to make it smaller and more manageable in that way. And you can then generate a point cloud that's more manageable for when you're creating surfaces for that. Just want to see, yeah, no, I'm good with that. Oh, the surface boundary, I just wanted to add that. If you do add that, so let's say you are happy with the surface, you don't want it to generate any more triangles to the outside, you can add a surface boundary, and that will define the extents of your surface. And then if you then add any points on the outside of that boundary line, it will not extend the triangles further for you again. So that's a way that you can actually ensure that you don't have any extra triangles being added to a surface as soon as you add a boundary to the outside of that surface. Good. Let's jump into the next example. Time still looks okay. Quickly go there. Next one I will do is I'll quickly look at some volume calculations and flatten the surface. I'll just show you guys an example of two stockpiles. There we go. Just waiting for it to quickly open up. And then we'll just look at two stockpiles. One is a nice clean stockpile that doesn't have any vegetation that's growing on it. The second one does have that. And I'll show you how you can use the flatten surface option to just ensure you have a better view of your stockpile and get better results there. So as you can see, we do have the two stockpiles here. I'll just quickly go and remove the unneeded stuff. So as you can see, we already created a stockpile region for the north and the south out of the existing scan that we had here. As you can see, if I remove them. So that is where the point cloud sample region comes into. The create region can be used. So you can actually then select the stockpile and tell it to add it to a new region, give it a name like North Pile or South Pile, and have that individual points form your scan into a different region, which is easier for you to then utilize going forward. So first of all, I'll quickly do this one. As you can see, this is a very clean stockpile. No unnecessary outliers that we can see. The data set is very nice. So obviously a quick and easy surface creation, and then a volume calc I'll quickly just run through. So we just create the surface. We call it the north. Oops, you help me spell there, north. Stockpile. Again, we can describe it. So this will be a stockpile. We'll make it that. And date and time can be added there. The members we want to do is we will just select that specific point cloud, and I'll go OK. Our surface will then be generated for the stockpile. We can add some contours quickly and then do a volume calculation as well. So there we go. A very nice clean surface we'll see. Let's quickly go into the 3D view. There we go. And as soon as I switch off the north pile points, as you can see, we do have a very nice clean stockpile. One thing the guys that have done quite a bit of scanning would have noticed, this part over here. Always be careful, guys, for scan shadow. Obviously, the scanner was this side of this little pile, and it never got any of the points behind it. So that can always be something that tricks up your stockpile calculation as well as your scan work. Always be aware of this shadow that can be generated by an obstruction in front of your scanner. As you can see, we do have one small outlier over there. Again, we can just select that specific point and remove it. I'm not going to do that for now. I'll show you in the flattened surface. For contours, again, easy to do. We'll just call it as is. It has already got a name. We'll run through it. As you can see, we'll generate 11 contours. If you change it to, let's say, 0.5, you will see that we up it to 22 contours. So again, quick and easy way before you generate the contours, have a look to see how many you will generate. Again, label the end, decide how far you want to go. to label them on everyone. So I'll just use it like that. And then there we go. I can then switch that off. And there we go. A nice, clean, tidy contour plan. As you can see, it added the labels there. And again, I can select the labels and you can actually manipulate them individually as well if you want to. So just remember, everything can still be edited afterwards as well on your contours that you've generated. That's a quick one there. Next stockpile, as you can see, we have quite a bit of vegetation that's grown on this one side of the stockpile. And cleaning this up, you can do by the manual way that I showed you to actually highlight those points and to remove them from your surface. I'll quickly show you a bit easier way to manipulate them. So let's quickly zoom out, go into surface, and we'll just first of all create the surface as it is. South stockpile. I'll call it that. I will make it a different color this time. And then we already have the point selected. Click OK, and we'll quickly generate the surface. And as soon as I zoom in, you guys will obviously see a lot of spikes in the data because of the vegetation that's on top. There we go. So now if we switch off the south pile there, oops, I switched off the surface and not the points. Sorry, there we go, wrong way around. If I zoom in, there you can clearly see we are having not such a good day with outliers on this section where there's quite a bit of vegetation. As you can see, we're doing a bit better over here. This looks pretty decent. But as soon as we move across and we're getting to the parts where the vegetation is, that looks pretty bad on outliers, and it will definitely add some volume into this calculation that is not going to be needed for this exact stockpile. So what you can do, as I mentioned, you can go select those points individually and remove them if you want to, or you can utilize the flatten surface function that we have. So now we can select which stockpile we want to utilize. You can tell it the tolerance. So I'll just go with 0.10 centimeters. As I see, it is scan data, and that should be fairly dense, so we should be above. The direction you want it, so from the surface up, what distance you want to look at by removing the points, or you can go below. You can use a boundary. So if you have a boundary on a specific area that you would just like to use, that area, you can do it. It will create a new surface for me, and it will include any break lines that I already have as part of my surface, if that was there. I'll just go to apply. And you will see that we now have a new surface that has been generated. So before I switch it off, I'll just quickly recalculate this and close this. So you will see we now have two surfaces. So what I will do is I will switch off the south one, and you will see the difference. So there you go. Quite a lot of the spikes were taken out, the outliers. It's not 100% clear. That is because the vegetation was quite dense around here. So the scanner never picked up the exact ground, or let's say the stockpile at certain areas. So as you can see over there, it will not know that that is an outlier because the height between this and the point next to it is very close to each other. Where areas where we do have a bit flatter section where we could see the stockpile underneath, it cleared out those outliers much better. So that's just one thing to take note. Again, with scan data, you will find that it's very dense and it will not always give you 100% clear answer. So you still need to do a little bit of manual cleaning up to have that. But at least this looks much better than what we previously had for our stockpile. If you want to do the volume calculation for this specific stockpile, it sits under earthworks report. We can do volume by grid. So I'll just quickly show you this. So that is where you can actually decide what grid you would like to utilize. I need a new plan view. That will help. Here we go. I just want to quickly add a new plan view here. For the grid, you can actually select what the grid interval should be. Should it be 5 meters? Should it be 10 meters for your volume calculation? So what we can do here is I'll keep that one on. If I go to surfaces and volume grid, you will see we can call it a name. So south, let's just call it that for now. Which initial surface and final surface you want to use. So you need 2 surfaces, and then you can select your grid spacing that you want to utilize. So over here, you can see that's small area, 1 meter grid. That will give you a calculation. It will give you a result, and you can compare it and see when you start tapering off in your results, and test it that way if you want to see how accurate the volume calculation is that you get by changing the grid size. Some guys like to have a smaller grid, get more accurate. Again, timing for the calculation will take longer the smaller your grid is. The earthworks report gives you an overall calculation as well. You have 3 options: stockpile depression, surface to surface, or surface to elevation. So obviously, if you had a surface that you measured before the stockpile was put down, you can obviously use that as your base surface and then your stockpile on top to calculate it using surface to surface, which will give you a much more accurate volume. I'll just use the stockpile depression. I'll use that flat option that I have. If you have a boundary, you can select that. I have one more example. I'll quickly run through it just to show you guys what that can do. If you click OK, I'll just quickly run through this and bring it across to show you what the volume report looks like as soon as it's done. The size of your surface will also determine this time it will take to calculate the volume. It should be done just now. Another option to do a surface to surface, which I tend to utilize, is if you generate a CAD boundary around your stockpile on the ground points that you have, just generate the surface using that CAD boundary. For the surface to surface calculation, it's obviously not 100% accurate to what the ground looks like underneath the stockpile, but at least you would take into consideration what the ground surface looks like around the stockpile when you generate that, and you can then utilize the surface to surface calculation that way if you want to. Was done. Here we go. And there you can see the volume report that you will get. So as you can see, the stockpile volume, depression you get over there, it will give you an area for surface geometry as well. And then the maximum depth and depression of the stockpile will be given as well. So that is what the stockpile report would look like when generating it. Last one, I see we have a few minutes left. It's just one last example I want to quickly share with you guys. When you have more than one or two stockpiles, like I have over there, just quickly close this. So this is an example of a stockpile yard. We have multiple stockpiles and you would like to calculate the volume for them. An easy way to get that done, and if it's a stockpile or stockyard that you might have to survey on a regular basis, the way I would go about that is generate CAD boundaries for each stockpile. And then when you have those boundaries in place, you can just use that file to import every time over your existing data that you have, and you can then manipulate your calculation that way. So what I will show you here quickly is I can actually, I've did separate everything out already. So I'll just quickly switch off everything. So we just have the ground left. As you can see, my boundaries that I've already drawn up. What I can do is I can go into my surface and create it. I'll just do test one quickly. I'll show you another way that you can, let's say that is stockpiles as well. I'll go with that. I'll select that quickly. Okay. So one thing you can do as well, if you just want to see the surface for these individual stockpiles on its own, and you don't want to see the whole surface that was generated, another way that you can manipulate the surface is by adding the stockpile boundaries that we have existing at the moment. So what I will do is I'll just quickly select all the line strings. And to make my surface smaller, I can just add these as surface members. And I will only have a stockpile, so surface members. I just want to add those 6. And I can quickly manipulate my surface to only be inside these boundaries that I've added. As soon as it gets it done, here we go. Did it add it yet? Nope, didn't add. Let's try again. Oh, they already bought. There we go. Just my luck. Let's see if they did what I wanted on the 3D view. Let's switch off the ground. Nope, they didn't do what I wanted to do. Members to add. And just my luck, it doesn't want to do it because I already have a surface that I've done it on, I think. Let's just redo that quickly. Delete it. Here we go. And let's just do a new surface. I already selected those boundaries when I created my first surface. That's probably what happened. Green. And then I'll just select this ground. There we go. Let's just redo that quickly. There we go. And then I'll just switch off that one and that one quickly. I'll just select those points and just remove that one. And I'll add them. There we go. Now it's recalculating the surface. So I'll just quickly switch it on. And it still doesn't do what I wanted to do, as a live demo should go and not do what I wanted to do. Okay. As it may be, just if you want to calculate the volume for these individual ones with the boundary already there, in the earthworks report, you can actually now include your boundaries. And if you then calculate it, it will give you the stockpiles inside these boundaries individually. Let's quickly run through that. Here we go. And as you can see, you have your stockpile analysis, and at the bottom is stockpile 3. So each of those individual stockpiles have been calculated as a volume now. As you can see, the volume analysis and then stockpile 4. And so it will go down with all of the stockpile boundaries that I added. And yes, I just get some feedback. I did use the wrong one. It's surface boundary and not members. Thanks for that in the chat. It's add not surface members, but surface boundary. And if you add that, it should give me the result I was actually looking for. There we go. That should be the correct functionality. Got the two mixed up there. Thanks for that. There we go. That's where I wanted to get to. So if you add the surface members as a boundary, this is the result you will get. So you will just have your individual stockpiles that you can view. This doesn't mean that the surface has disappeared or been deleted. That's in between. That is still over there. But now it's just easier to view each individual stockpile, and the volume calculation goes along with that boundary that you've selected. So that's where I wanted to get to that. That took a bit longer than I expected. Sorry, everyone. I see there's quite a few questions. VM, thanks for running through them and answering as we go along. We do appreciate that. And thanks for the effort there, VM. I'll just quickly run through the last bit of the slideshow. So just resources. Guys, if you want to view this